everyone can see that screen. So today I'm going to be talking about a project we've been working on called 825 Pacific Ave, what we've deemed Artscape. So this is a building that's put together by a bunch of different partners here. It's developed by Grosvenor. So this that's the property wing of I think the royal family there. So as Sean said, this is potentially the Queen's first passive house. And then the rest of the design team includes Integral, IBI, and Ledcor is the contractor. So it is located in downtown Vancouver and some other highlighted areas of the local Vancouver map here, but it's kind of nestled in a bunch of kind of fairly high-rise towers, and there's a whole bunch of other buildings that are going up in the downtown core that are all going up, several, 50, 60 stories up. So it's kind of this tiny little 7-story building that's kind of right at the base of some of these other towers. Now, Vancouver is a fairly temperate climate. Our average winters are about 5 degrees Celsius, sorry, folks in the States. But our design temp is around -5. So we do drop below freezing on occasion. And we get about 2,000 hours of sunlight annually. But because it's nestled in this building, between all these tall buildings, we didn't really try to approach it as trying to take advantage of a lot of that solar heat gain, because we knew probably wouldn't get a whole lot to begin with. Now, again, this is a smaller part of a larger development. There's a next door residential tower also being developed by Grosvenor. And so it was kind of put on as a requirement to build this kind of community space and to go passive house from the city of Vancouver. Because in the end, this will be turned over to the city of Vancouver to own, and it'll be operated by a nonprofit association. And the intent of this building is to really house artist studios and offices and an event space for gallery exhibits. Now, right now, the exact tenants and all the interior equipment and tenant fit out is not quite known. So we don't know the full operations yet. So that'll come up a little bit later. But so far, we have been pre-certified under the Passive House Classic, and it's about midway through construction at this point. So for the layout of this building, it's got a fairly narrow shape. But it's a pretty simple geometry. So it's very kind of square, rectangular shapes along the building. So there's not a lot of articulation or anything to worry about there. And then on the interior, we've got some very kind of open concept, again, meeting that kind of up to the tenant sort of approach. But the idea here is to really have an open concept. Now, where we started in the design, kind of going for passive house in this case, was want to get a good head start. So we looked at kind of at the glazing systems first. And this is where we kind of settled on, it's Grosvenor, they're willing to kind of spend the money for this. So we went with the triple glazed fiberglass window. It's locally designed and manufactured in the Vancouver area. It's been passive house certified. And then we've got roughly about a 20% or just over 20% window to wall ratio. And it's kind of a mix of operables and fixed, so that we can still, take advantage of some of those, natural ventilation streams in the summertime. And kind of, you can see the spacing of the windows here and kind of the division of how many kind of operables to fixed windows that we have, just on a characteristics section. Now, the one thing that we really needed to kind of consider or figure out in that beginning design is that this was intended to be a non-combustible building. So if we're, based on code and life safety, if we're using a combustible window product like a vinyl or potentially a fiberglass window that doesn't necessarily have fire testing for it, then there needs to be some additional considerations in the design. So in this case, in our local codes, what it requires is that at least a 1 meter separation between those windows. So in case there is any kind of fire distribution, the flame spread doesn't quite reach up to the next combustible window. And then also to make sure that we have less than 40% overall glazing on that particular facade. So in order to do that, they essentially designed the windows to be kind of staggered to provide that 1 meter separation. And then we have mineral wool insulation on the exterior. So again, this was our particular code. Depending on where you are, there may be additional considerations, but this allows you to use some of these non-combustible or combustible windows that are a little bit higher performing than aluminum on a non-combustible building. When it came to the actual envelope of the actual wall system, we initially started off pretty thick. We were looking at about 10 inches of semi-rigid insulation on the outside, and then looking at, thermally broken cladding system, and then some interior insulation as well, simply because we really couldn't take too much advantage of the gains from solar heating just because of the project location. So this was quite, a thick wall, right? And knowing that, where the buildings are and adjacent to the adjacent buildings in comparison to the lot lines and everything like that, we were kind of struggling with that thickness and trying to come up with some other solutions. This is where kind of the advice or working with the contractor and the subtrades at this point to kind of optimize the envelope really came in handy. So the initial clip system we were looking at is a fairly typical one. It's a pretty good performing clip system. But when we approached the subtrade, they actually provided an alternative. So we went through a couple of different optimization kind of processes. The first one was we ended up changing the steel stud gauge on the interior side. This allowed us to kind of provide a little bit more strength for that wall. And that way we could space off the cladding attachment system a little bit further. So instead of 16 inches on center, we were able to go every other stud at 32 inches on center. And then the subtrade provided this clip system here that provided an improved way of holding up the cladding because of this kind of key-in system. It's able to take a lot heavier dead load or cladding weight on the front of it. So this way we're able to actually continue, be able to space off those clips even farther apart and still maintain the thermal performance that we're expecting. So with that, we're able to, and we made some additional adjustments in our PHPP model, but allowed us to essentially go from 10 inches and cut down to 8 inches. So now this was a lot more reasonable and allowed a little bit more space and reduce some of the construction costs and material costs. At the same time, because we have so much insulation on the outside, we have a little bit of insulation on the inside, we're actually able to kind of take a look at that hygrothermally. And instead of doing, kind of removing the interior poly and putting an impermeable membrane right on the sheathing, because of those ratios, we're not so much worried about anything condensing on the backside of that sheathing. So you can kind of see we went through the optimization process. We kind of took a look at the different clip systems and found that yes, we could make this work with the proposed clip system. Now, when it comes to some of the detailing, the window details, we've really tried to push these fiberglass windows off the steel studs and reduce that thermal bridging and nestle it right in the middle of the exterior insulation to kind of minimize that psi value. So in this case, you can see it kind of in the top right corner, the way we've kind of set it up here. We were able to even get it down to almost essentially thermal bridge free for this head detail, right? The way that we've kind of set it up. Now, the one thing to consider is, we did have to put in some areas an additional support angle where it wasn't able to kind of align and tie back to the structure all that well. But for the most part, we were able to kind of get away with not having to do that when we took a look at when we went through the shop drawing process. Other details kind of that seemed to make an impact was the below grade transitions, where, just trying to figure out how far down to bring the insulation. We do have a large raft slab on the bottom, so they didn't really want to insulate all the way down past that. It becomes very, very difficult. So we tried to optimize and using thermal modeling, figuring out exactly the depth of that insulation where it has to go. And we can find it just really needed to come up to the top, and really beyond that didn't make too much of a difference on that linear transmittance value. And of course, there's a bunch of other details, kind of standard, wrapping the parapets with insulation, pushing the doors out. One in particular, just kind of wanted to mention to everyone that we're trying out here is, in a lot of cases, we need to have through wall flashings every couple of stories to kick out any water or rain that comes through our rain screen system. So in this case, we have so much insulation on the outside, we're not worried about too much water getting back there, but we still need something. So we're, instead of using a continuous metal flashing, which is a linear, can have a pretty decently large linear transmittance across the face of the building, we're looking at doing some non-conductive or two-part flashings. So in this case, we have a peel and stick, a through wall peel and stick that's just lapped onto a kind of a shaved mineral wool insulation. And this actually does provide a decent amount of support for this system and still able to kick that water out without having to have a metal, continuous metal flashing going through the whole system. And it's a very similar kind of approach with the base of wall detail. And in fact, it's even easier because you can shave, put a piece of shaved of XPS or whatever kind of rigid insulation that you have on below grade and really make that connection across the whole face. So in this case, we were able to greatly reduce that thermal bridging around the entire building. And because of the building shape really, and the height of the building, some of these stuff does start to add up in terms of that thermal bridging. So you can see here just all of our different thermal bridges that we've used, you know, pretty low values in the most part. The greatest ones are I think the below grade ones and some of the screen supports on the roof, but they're, you know, very, very small linear lengths on the building. So that was found to be acceptable. In terms of the lighting design, we tried to make it as efficient as possible. And then for the mechanical systems, we're using heat pump systems for hot water. We just found that provided a little bit extra help with the PE targets. And then on the other side, we're using a single centralized ERV system, which then goes and connects into another heat pump VRF, which then provides additional heating and cooling for each of the spaces. And you can see here our current targets. The heating demand is at 13, so we still have quite a bit of buffer, which is nice. And then, you know, our PE is at 117, so we're kind of edging a little bit closer, and we've just kind of left that buffer for anything else that kind of pops up during construction, right? So if there are additional change orders or anything like that, at least we know we have the room to play around a little bit. So we're pretty confident about being able to maintain this throughout the rest of construction. In terms of the actual construction, we've had a great partner with Ledcor. They've really put together a pretty good process for everything. We've worked with them to set up you know, workshops with the trades and just make sure that everyone's on board with the whole approach when it comes to, you know, maintaining the air barrier, dealing with any kind of you know, change orders or you know, things that just come up during the construction process. One of the big things that was very, very helpful right at the start of the construction was to create a building mock-up. And so this was done to just take a bunch of these characteristic details. And then all the trades kind of came in, all worked together to build this mock-up so they could do the sequencing correctly. They you know, worked it out between each of the trades to figure out exactly how they were going to put things together. And then obviously, you know, the one thing that everybody always dreads to see on a shop drawing is, you know, by others, where, you know, something one group is doing, they assume somebody else is doing, and then potentially gets missed on site. So this helped work that out, where we're there with the contractor and the sub-trades, that, you know, all of those missing pieces were put together and given a responsibility to one of those groups. It was also very convenient because they use this mock-up as a first stage for an air leakage test. So we set the whole thing up with the air leakage testers, and it wasn't a quantitative one. They weren't getting an ACH out of this, but it was really to do a smoke test to really figure out, well, what did we do on these details that, you know, was there something off? Was there something that was just pouring out smoke? So they were trying things like, you know, where the clips went in, they tried to pull the like as if on site, you know, if they put a clip in and had to pull it out because they missed the stud or something like that and left a hole, could they patch it up correctly? Or what would happen if they, you know, if something wasn't sealed the way that they thought it would be, and just see what happens with some of that smoke. So that allowed us to at least sort some of those kind of remediation pieces out very early on. Now you can kind of see here with some of the progress photos. Here's the below grade getting installed with all the below grade insulation. Of course, we've all measured that out. And then as they've gone up the building, they've started to do some of the lower roofs and putting in place, you know, place areas for thermal breaks and other pieces that have kind of been embedded into the slab. This is what it's like, I think, as of a couple of days ago. So they're starting to sheath the building, and then on the ground floor and second floors, starting to put in some of those window systems. So the next steps will be at around level 3. Once that's all buttoned up and the membrane and everything is put on, that's when we're going to go through our first air leakage test for the first three levels. So yeah, that's the building, and I think I'm right on time.